In this lesson, we're going to continue finding solutions of systems of linear equations. All right, we're asked to write the system of linear equations represented by the augmented matrix. Then we're going to use back substitution to find the solution. So for example 1, we can see with the 3 dots here stacked in each row that those represent the equal signs. So with 2 numbers to the left of these 3 dots, we know that we have 2 unknown variables of x and y. So we've got x minus 2y equals 4 and 0x 1y equals negative 3. Well, this is easy. So we've written the augmented matrix. Now we need to use back substitution. So if y is negative 3, then we're going to find x. X minus 2 times negative 3 equals 4. That's positive 6. Subtract a 6, so 4 minus 6 is negative 2. So our solution is negative 2, negative 3. All right, so this matrix is in row echelon form, but look how easy we can find the solutions when our matrix is in reduced row echelon form. This is reduced row echelon form. So we can jump right off and say 1x equals 7 and 1y equals negative 5. So let's write our solution as an ordered pair. Easy enough, our solutions were 7, negative 5. I guess I'm going out of order. Let's go to example 2. So I guess I'll write over here. We have 3 numbers to the left of the stack of 3 dots, so we must have the variables x, y, and z. We have 0x, 1y, minus 1z equals 2. And this last row is convenient for us because 0x, 0y, 1z equals negative 2. So z equals negative 2. Let's next find y. So y minus, and z is negative 2, so y minus negative 2. Y minus negative 2 equals 2. So this will be y plus 2 equals 2. We'll subtract a 2 to both sides, so y equals 0. And let's find x. So x minus y, y was 0, so y minus 0, don't need it. Plus 4 times z was negative 2, and that's supposed to equal the 0 up here. So x minus 8 equals 0. Add an 8 to the other side. X equals 8. Our ordered triple is 8, 0, negative 2. So this matrix was in row echelon form, so we had a little bit of back substitution to do. But notice in example 4, the benefit of having an augmented matrix that's been put in reduced row echelon form. You got the ones down the diagonals with the zeros up above or below all the ones. These are going to be our solutions right here. So 1x equals negative 4. This is in the y position, equals negative 8. And 1z equals 2. So negative 4, negative 8, and 2. So just these values right here would be our solutions. So reduced row echelon form has great benefit to us. We can avoid the back substitution. It's just that when we put a matrix, an augmented matrix in row echelon form, that's a lot of work. So then to even go further to reduced row, that'd be almost too much work. Now, enter the calculator. Finally, it says use matrices and a graphing calculator to solve the system of equations if possible. We're going to write the augmented matrix. That's the first thing. Then we're going to use the feature on the calculator called reduced row echelon form to put the matrix in reduced row echelon form. The calculator will do that for us. We'll record that, and then from that matrix, we'll state the solutions as a solution as an ordered pair, triple, etc. Okay, so first step, you have to write the augmented matrix. So thank gosh we don't have to put this in row echelon form or reduced row echelon form. So here's our augmented matrix. Let's let the calculator do all our work for us. Let's first find the RREF. So go to matrix, which is above the x to the -1 key in blue. So hit second matrix. How about if I turn it on? Second matrix, over to math, and then just arrow down until you get to RREF right here. Option B, press enter. Now we want to build a matrix right here. So we're going to hit the alpha, the green key, and the zoom key. We're going to customize our matrix. So let me slide this over so I can see what I had. We have 2 rows and 3 columns. So 2, come down here, 3, come down to OK. It builds it. And I'm just going to hit those values. 1, right arrow, 2, 7, right arrow, 2, 1, 8. Double check, make sure I entered everything correctly, press enter. We'll record this matrix. And remember right here, these are our solutions. So 1x equals 3 and 1y equals 2. 3, 2 is our solution. Easy enough. All right, example 2 is over here. Let's write the augmented matrix. Pick up the calculator. Second matrix, over to math, arrow down, enter, green or alpha, zoom. Let's see, this is 3 rows and 4 columns. So let's customize 3 rows, 4 columns. Okay, got it built. And just be careful with your entry. If we make a mistake with our entry, we won't get a real pretty matrix. So we'll know we made a mistake. All right, one last quick check. Yeah, everything looks good. Record. All right, so this last column are our solutions. And remember we had X, Y, and Z. So 1, -1, 2. All right, you can complete the last 2 on your own if you want, and then come back and check. Know what X is. So 0, 4, 2, -1. 3 by 4 again. So that last column would be our ordered triple. what's that, a 4 by 5? Looks like this is going to be X, Y, Z, W. Typically is how we do that, X, Y, Z, W. I know that's a little strange. But our ordered quadruple would just be the numbers that we got from the last column. And that's it.